What actually is logic? You, at some point in your life, probably have said something like, the point you're making doesn't make any logical sense, or just be logical, not emotional. But if I stopped you right now and told you to actually define logic, you might just say something like it means being super smart, which low-key, that's valid, but not really. So let's back up a second and imagine this. Imagine you're trying to solve a puzzle. You don't know the answer, but you do know what can't be the answer. So you go, well, it can't be that one because that one would contradict what we already know, and it can't be that one because it breaks a rule, so it must be this one. I'm sure you're familiar with doing something like this, and that little chain you just built, that is logic. Logic is basically the study of reasoning. It's about what follows from the what. Like if A is true, and A implies B, then B has to be true too. It sounds simple, but it's actually a whole structured system for figuring out whether conclusions really follow from premises or if we're just fooling ourselves. Alright, if we zoom out a bit for a second and go a bit more formal, the word logic actually comes from the Greek word logos, which meant a bunch of things like word, reason, order, and structure, and that's where we get words like biology, psychology, and even dialogue. So at its root, logic is about keeping our thoughts in order, making sure they actually connect in a way that holds up. And actually, there are 3 ancient laws that we all follow, but we'll get to these soon. For now, you may be asking, what does logic then actually look like in practice? Well, there's formal logic, which is the super precise, like math level precise kind of logic. It uses symbols, operators, and strict rules, kind of like programming. Think of stuff like, all humans are mortal, Socrates is human, therefore, Socrates is mortal. This is a syllogism, one of the oldest forms of logical argument, and it works because the conclusion follows necessarily from the premises. If the premises are true, the conclusion has to be. Okay, then there's informal logic, which is more like what we use in conversations, debates, essays, and daily life. It's about spotting whether an argument actually holds together or whether someone's just using rhetorical tricks, emotion, or noise to make something sound convincing when it really isn't. And this is where logic becomes kind of powerful and scary, because the world is full of nonsense. People argue online using what looks like logic, but are actually logical fallacies, a failure in reasoning which renders an argument invalid. These are things such as strawmen, slippery slopes, ad hominems, and a million other tricks that feel persuasive but break apart once you look at how logic is actually structured. Learning logic helps you see through that. It's like X-ray vision for arguments. You start being able to go like, wait, that conclusion actually doesn't follow, or that example you're saying doesn't support what you're claiming, or they just redefine this word halfway through their argument. And doing things like this, suddenly, you're not just reacting to arguments emotionally, you're analyzing how they're actually built. But as much as logic is important for calling out other people, it's also about noticing your own weak spots too. Like when your beliefs rely on double standards, or when you realize 2 things you actually believe contradict each other. So in that sense, logic isn't cold or robotic, it's actually humbling. It shows you whether ideas don't fit together, which isn't a failure, but the beginning of clearer thinking, which matters because whether you're designing a computer program, deciding how to vote, arguing with a friend, or just figuring out your own beliefs, logic gives you a structure to think with. Okay, now going back, remember how I mentioned there are actually 3 ancient laws that we follow? Well, at the foundation of logic, there are actually 3 classic rules, often called the 3 laws of thought. These go all the way back to my boy Aristotle, and they still shape how we reason today. They seem really simple at first and kind of obvious, but they actually do a lot of the heavy lifting behind the scenes. They're kind of like gravity for thinking. First is the law of identity. This one is pretty simple, but it's everything. The law basically says that a thing is what it is. Yeah, it's actually that simple. It's basically saying in variable terms, A equals A. If something is true, then it's true. Now, that sounds obvious, but it lays the groundwork for all consistent thinking. If we don't treat things as being what they are, then any kind of discussion collapses. Like, if truth meant something very different every time you said it, you couldn't argue about anything at all. The law of identity says, pick a meaning and stick to it. Second is the law of non-contradiction. This one says something can't be both true and false at the same time in the same way. Might sound trippy, but it's basically saying something like the cat is on the mat and the cat is not on the mat can't both be true. unless you're playing games with words. This is the law that stops logic from exploding. It's what lets you detect when something's off. If someone says, "I always lie," that's a contradiction, because if it's true, then it's false. The law of non-contradiction is what keeps your beliefs from crashing into each other. Think of it as a blocking internal conflict in your system of thought. Now the last one is the law of the excluded middle. This law says a statement is either true or false, no in between. It's like flipping a switch, either on or off. So for example, saying something like "the light is on" is either true or not. Now, this gets tricky with vague language, because when you ask something like, "Is this person happy?" it's not always clear what counts as the true versus the false, the happy versus the unhappy. But once the terms are defined clearly, logic treats it as either true or false. In formal logic, you need this law to make clean deductions. It forces you to take a stand, yes or no. Logic doesn't really like maybes unless you define what maybe even means, but then that just becomes a true or false kind of. It just gets kind of complicated. And just to be clear, these last two laws aren't saying the same thing. The law of non-contradiction says you can't have both, and the law of excluded middle is saying you must have one. They're like working together. One prevents overlap, the other prevents gaps. Without them, reasoning kind of turns into a soup. These three laws are like the rules of the game. But you might be saying like, okay, cool, but where did these rules even come from? And good question, because some people think logic has always existed. Kind of like gravity. It's not something humans invented, but something we discovered. Plato, for example, believed that abstract truths like logic live in a timeless, perfect realm waiting for us to uncover them. Others think logic is more like language, like a tool humans developed to make sense of the world. In that view, logic evolves just like how our understanding of science and morality evolves. Now, there's a bit of vagueness in all of these terms, but for simplicity, we'll skip them for now. Okay, then there's Aristotle. He's often called the father of formal logic, because around 2,400 years ago, he laid out a system of reasoning that looked a lot like geometry: rules, premises, conclusions. And while the details have changed, the basic shape he gave logic still is around today. But that raises even weirder questions. So if logic is a human invention, can it ever be wrong or biased? Or if it's universal, then how come different cultures sometimes reason in different ways? And is it possible that some alien civilization could have totally different rules of logic that still somehow work? Or would that just be nonsense? You can see stuff gets weird really fast. So, how do we even know that logic is valid? Another good question, and that's surprisingly hard to answer. Because look, here's the catch. Trying to prove logic with logic gets circular really fast. When you're trying to prove logic using logic, you end up using the very rules you're trying to justify. Now, some thinkers say logic is just self-evident. Like, if you understand the law of non-contradiction, you see that it has to be true, because denying it just leads to nonsense. Others say its validity comes down to how well it works. If logical systems help us build rockets, diagnose diseases, and invent computers, then maybe that's all the proof we need. But skeptics push back. They ask what if our logic only works because it fits in the kind of world we evolved in? What if there are other logics out there that are fit for different realities we can't even imagine? And some mathematicians actually explore that, like pair-consistent logic, where contradictions can exist without collapsing the whole system. It all sounds pretty crazy. So, logic might not be a one-size-fits-all, but like a set of tools shaped by context and consistency. But here's the twist that most people don't want to hear, which is that logic itself depends on what you ultimately assume to be true, which are your axioms. And the talk of axioms are very, very tricky. If that sounds weird or confusing, or you don't know what axioms are, do not worry, we'll get to that right now. Think of it like this. So before logic can do its job, you have to accept its starting rules. Those starting points are called axioms. They're the basic assumptions you agree to take as true without proof. It's kind of like the rules of a game. For example, you don't prove the rules of chess before playing the game, you just accept them, and then the game makes sense. So kind of like that, axioms are your starting points. They're not the things you prove with logic, they're the things you need before logic can even start. They're like a foundation you build on. So for example, you might say well, of course, a thing can't be both true and false at the same time, but that's you presupposing the law of non-contradiction. And logic didn't prove that, logic uses it. And this is where things start to get weird and funky and sus, because once you try to justify your starting assumptions using logic, you've already assumed the thing you're trying to justify. It's a circle. That's why philosophers say axioms aren't proven, they're adopted. They're like the lenses you put on to make the world legible in the first place. So, if someone says, but how do you know logic is valid? You might have to just shrug and say, I don't know, not in the way that you might want. But what you can say is that logic has been incredibly useful, consistent, and reliable across a lot of domains, like mathematics, science, law, coding, reasoning. It's earned our trust. But even then, that trust rests on a leap into a framework we can't fully escape, but can't also fully justify from within. So, what actually is logic? Well, basically, it's the frame behind our thoughts, the filter that helps us separate the "this makes sense" from "this just sounds good." It's what lets you spot errors in your own thinking and sometimes in the world around you. And maybe most importantly, logic doesn't always give you the right answer, but it does give you the structure to check if your answer even works. If this all interested you and you want to go deeper, check out these pieces of writing right here, or honestly, just grab a notebook and try breaking down an argument you hear this week. Like, what's the claim? What are the assumptions? And does it really follow? Because once you see how logic works, you can't unsee it. And that's when thinking really begins. Thank you for watching, but before you go, this video is going to cost you a subscribe, and I'm just going to flip this around so you can leave tips in the forms of likes and comments down below. Goodbye!